All right, who's not excited about this one? Installing VMware's ESXi on a Raspberry Pi 4. Now we can actually run Raspberry Pi 4 ESXi clusters managed by vCenter all on, a little Raspberry Pi the size of your hand. It's really, really fun and it's really, really cool, but it is a little bit of a process to get it stood up the first time. But that's what my job as a trainer is. It's to kind of suffer through figuring these things out so that you don't have to. Now, fair warning, before you get started, there are some things that you need to have up front in order to get Raspberry Pi 4 and ESXi up and running together. Here's what they are. You should get the Raspberry Pi 4, preferably the 8 gig of RAM kit. It will work on the 4 gig of RAM, but you really want to get the 8 gig of RAM kit because it's stable and there's a little bit less config that you have to do. So you get the Raspberry Pi 4 8 gig kit. That comes, usually, make sure you get a kit that comes with an SD card. Those SD cards come with the ability to install the Raspbian OS directly off of the SD card that ships with the box. And that's going to save you a whole lot of time and a whole lot of headache. So we've got the Raspberry Pi kit that comes with an SD card so that we can install the Raspbian OS. That's actually one of the first steps that we have to do. The other things that you're going to need to make this happen is you're going to have network connectivity, and you're going to have a monitor that you can use to actually plug the Raspberry Pi into via HDMI. This is just so that you get the basic setup going. Once ESXi is up and running, you can kind of rip it all out. But you do have to have a network, you have to have the Raspberry Pi, you have to have a monitor to plug it into, and you have to have a USB keyboard and mouse. That way you can actually go through the configuration steps too. Then the last things you need 2 USB thumb drives. One is going to be the installer that you can use to install ESXi. The other is going to be the target that we install ESXi onto. So we're going to have 2 USB thumb drives. This one will be installing, and this one will be the place that it gets installed to. Then, once it's installed, we'll pull this guy out. The installer will pull it out. So we're only left with the USB thumb drive that has the installation on it. That way it boots from this. And we can reformat the installer drive to now be our data store. So we've got 2 USB thumb drives in play here. Basically, what I'm saying is the target one that's going to be what we install ESXi onto, that one can be kind of small. In my case, it's 14 gigs. The one that we use for the installer that's also going to become our data store, I actually used a 128 gig thumb drive. So that's all the pieces that you have to have up front. You have to have the Raspberry Pi kit, preferably one that comes with the SD card so that you have Raspbian installed. You have to have a keyboard, a mouse, a network, and an HDMI monitor. And then you have to have 2 USB thumb drives. That way one can be the installer and one can be the target. And then we'll repurpose the installer drive to be our data store after the fact. So with all that being said, let's now talk about the steps to make ESXi on the Raspberry Pi come to life. Now, for the most part, this was my first time doing this operation, so I stumbled along the way. Let me just go ahead and set up the workflow for you right now so that you understand what's going to happen. The first thing we do is we assemble our Raspberry Pi. We physically put all the pieces together, and then we boot it up with the SD card that comes with it, so it boots up with Raspberry Pi's OS, the Raspbian OS. You walk through the initial steps here, that's what you're seeing on the screen. Just to get it up and running, it'll go through a reboot process. You make sure it's got all the latest packages and so on. And then we just have to make sure it has this, the latest EEPROM update. You're really just looking to make sure that the current thing that's listed here matches the latest thing that's listed here. Once that's up and running, we're going to yank that SD card out. It's no longer going to boot off of Raspbian OS. We're going to reformat it so that it goes into the actual firmware configuration itself. You see, the Raspberry Pi, when it boots up, it doesn't give all of the necessary resources to ESXi that it needs. In fact, it actually limits the operating system to only 3 gigs of RAM when we actually have 8 gigs of RAM. So we're going to walk through all of these steps to reformat that SD card so that it boots into the UEFI menu, which kind of looks like this down here. And we go through the configuration steps to set up the firmware itself so that ESXi can boot off of it. It's not bad, but just know that this is the process. Once that's been done, we need to set up our USB thumb drives so that we can install ESXi. One USB thumb drive will be the installer, one will be the install location, and then from the boot manager, we tell it which drives to boot off of. That way it eventually boots up into ESXi. Lastly, we have to configure ESXi itself to actually handle the USB thumb drive as a VMFS data store. We'll walk through all of those steps too, and at that point you'll have ESXi up and running. So let's get started. All right, let's put together a Raspberry Pi. Let's unbox all the stuff and see what we got here. We got a little Pi case. Looks like that's gonna be fun. I think I can just snap some things apart. Yep, pretty basic. Open up the Pi box. This is the Pi 4, 8 gigs of RAM. Gonna turn this into an ESXi server somehow, I think. Now, let's see what it wants me to do here. I already forgot how this went. Did it go like this? Off to a bad start. Just place that right there for the moment. Did it go on the bottom? Like that? No, that's definitely not it. Pretty sure this goes on top like this. Definitely goes on top like that. Looks like there's a little slot for the fan to go. So this should be, pay attention to those slots. Something, just trying to make sure I can reassemble it correctly. Yeah, that's gonna look good. Okay. So if I just set it right there, not bad. Very simple. But you know what? They did provide me with heat sinks to put on these things. So I should probably do that first, don't you think? There we go. All right, so let me take this back apart. Should be able to just kind of eyeball where these things go. Like, it looks like that guy would go right there. Would this guy go here or here? And with this guy, where would you go? Would you go here? My little fingers are not good at this. So the first one I'm going to do, I'm going to peel the little sticky stick off of this. This is the heatsink that's going to go on the processor. This is the biggest one. And it goes kind of, right, it's kind of square looking, right? So I'm going to just even it up and plop it right on there. There we go. Just trying to make it look nice and even as much as possible. Second one is going to be the long one. Struggling to peel the blue sticky off without pulling the entire glue off here. There we go. This is going to go right next to it. Again, my very fat fingers. Not precise. I did pretty good there. Happy with that. And then the last one, the little guy, goes right here. Kind of in the middle one, right? Dead center here. So here we go. Fat fingers again. Putting that right there. Little heat sink. All right, the fan. Fan has two cables, a red and a black one. I can split them out like this. And then we've got all these pinouts right here on the top. So what I want to do is I want to start with the one that's farthest away from me. That's going to be the one that's in this top left corner. And I'm going to skip one. The second pin is where the red cable goes. So what I'm going to do is I'm going to put the red cable on. just like that. And I'll kind of hold it up to the mic or to the camera so you can see. You can see I skipped one, and then the red cable went on. And now the black one goes right next to it. So skipping one again, you can kind of see. If I can just try and get autofocus to work with me a little bit. There we go. And now we can see the layout for each of the heat sinks. Now this little case has a slot for the fan. Important to note what direction the fan should blow in. The fan wants to blow down, so I'm going to put the CanaKit symbol facing downward. So it looks like this, but the mid tier comes on next. So I'm going to slot the fan through that and then slip it down onto the base. Now I'll slot the fan into the slot where it says CanaKit is just going to be facing downward. Let's kind of do it like this. And I can safely put the lid on top. There we go. Raspberry Pi 4. All constructed. So the power is USB-C with a little switch. So I find it's labeled USB-C power right here. I have a micro HDMI to regular HDMI cable in the event that I need to hook this up to a monitor. You can go ahead and take the micro HDMI end off, plug it in right next to the USB-C port. Let's see, they are labeled HDMI 0 and HDMI 1. 0 base is obviously going to be my first one. Now lastly, I'm going to need to put some Ethernet so it's got onto the internet. And then I'm going to load ESXI onto an SD card, which is then going to go in here. Then it boots up. So at this point, let's just move on to the ESXI setup portion. So first things first, if you Google ESXI on ARM, we see this ESXI ARM edition link that comes up here. If I give that a click, it takes me here, and the temptation is immediately to click this ESXI ARM ISO. I don't know if that's the right thing or not to click. I'm going to guess that if I click it, it's going to tell me I need to log in with a username and password anyways. So check this out. It says to get started, head over to the Requirements tab anyways. If I click the Requirements tab, it tells me these are all of the appliances that are supported. Raspberry Pi 4B, the 8 gig model, is highly recommended, and that's what I'm using is the 8 gig model. So scroll down here, download access. To access ESXi ARM, you'll need to register for a My VMware account. Registration is free. Let's give it a click. And finally sign up. Activate the email address. Type in the password. And now I'm finally registered. So now back on this ESXi ARM Edition page, I'm going to click Login, and I'm going to try and log in with that account that I just created. I'll say Login, and of course it says invalid username. Let me just try and check this off and click Download and see what happens. Okay, well this is looking a little bit better. Let's choose the ESXi for ARM ISO image, no VMware tools. I'll choose download. I agree, accept. Save as. I'll just dump this on my C drive. Nope, I won't. I'll just dump this on my D drive. And there, now I have the ISO finally downloaded. It now tells me overall ESXi ARM documentation, hardware-specific installation PDF guides can be downloaded on the ESXi ARM Fling download page. Select drop-down. Ah, yes, sure enough, right there on the drop-down, Fling on Raspberry Pi. That is exactly what I want to download. Let's try and download that. Let's see what it says. We've got the required supporting hardware, power supply, everything looks good there. HDMI. All good there. Okay, preparation. It says you need an SD card, mouse and keyboard, HDMI screen, Raspberry Pi Imager tool. So let's get the Raspberry Pi Imager tool for Windows. So let's put this preloaded Raspbian SD card into the Raspberry Pi and boot that. So here we go, booting that up. Let's give it a shot. Here we go, as it's coming to life now. I can see I've got the option to install Raspbian, which is what I want to do, I believe. Let's just do the Raspberry Pi OS 32-bit. With my mouse, I'll check that off and choose Install. This will install the selected operating system on that SD card. We'll say yes and let it install Raspbian. Now this came with the CANA kit itself. So we'll let it sit and think about things and get done installing and come back to it when it's done. And the OS shows that it was successfully installed, so I'll click OK and let it reboot. The Pi slowly but surely comes to life. And now we're ready to enter the initial config dialog, which is all good stuff. I'm going to change this to United States, American English, everything else looks good. Like use English language and use US keyboard. It wants me to change the password. I'll just set this to something like admin. We'll skip the screen setup. We'll skip the wireless network setup. And we'll update software. Setup is complete. It may reboot one more time. And the Pi comes to life. Now I'm going to bring up the terminal. Let's see if I can ratchet up this font size to be really huge. Ah, that's a lot better. So I'm going to give it a sudo apt update, just to make sure I've got all the latest packages and updates first of all. Looks like I've got some upgrades to do, so now I'll say sudo apt upgrade and press enter there. Capital Y to all of these things and say yes, go ahead and upgrade it and update it. And it's finally done. So now if I jump back to the 4K screen, here's the thing. We need to run this command, sudo rpi EEPROM update. So that way we can see if we have the current and the latest version are matching. So let's jump back to the Pi and give it that command, sudo rpi-EEPROM update. Looks like we are on the latest version. So our final step here with this Raspberry Pi is to shut it down. So we'll say sudo shutdown, and then we'll jump back to the Windows computer where we'll prep the SD card so that it boots into the firmware configuration. You see, we have to go into the firmware configuration so that we tell it what all hardware can we expose to the operating system, and then we need to tell it the boot order. It needs to boot off of the installer USB drive. Then, after it's installed, we'll boot off the installed USB drive. So we'll shut down the Pi and jump back to Windows real quick. Okay, jumping back to Windows here. So what we're going to be doing now is preparing the SD card so that it boots into the UEFI firmware section. So there's got a couple things we need to download here. We need to download the latest Raspberry Pi official firmware, and then we have to download the community Raspberry Pi 4 firmware. If I scroll ahead here, it looks like we're deleting out some kernel files And then we're adding the community firmware into the boot image. That way, ultimately, when we slap this new SD card in, it's going to boot into this environment, which is where we can actually configure the Raspberry Pi device and the boot order. So now, according to the docs, we have some work to do with this SD card. This is the second SD card that we're going to use to boot into the UEFI mode so that we can configure our Raspberry Pi to allow the RAM and boot from the correct order and all of that good stuff too. So looking at the documentation, we have to format it. We have to extract those files that we just downloaded, those Raspberry Pi firmware and the UEFI community firmware. And we've got some extra additional steps that we need to work here. So let me plug this guy in. Okay, it's plugged in, and we need to format it with FAT32. So let's do that. Scroll on down here. It's going to be my removable disk. Let's say format. It's going to be FAT, and we'll label it UEFI. Okay. So here we go with the dialog. I'm going to set the capacity to the max, FAT32. You know, I guess I could leave this as the 1612 kilo. Interestingly, their little screenshot says 512 bytes. I guess it doesn't matter. I'm going to give it the label of UEFI and quick format. Let's just let it roll. Format compete. And there we go. Now I've got this little USB or SD card here configured as my G drive. So what it tells us to do is extract the firmware master.zip file and then delete the kernel, whatever's highlighted here, images within the boot directory, and then copy the entire boot directory onto the newly formatted SD card. So here's what I propose we do. Here's the file here. We've got firmware master. This is the zip file that was downloaded. I'll go into boot. And what I'm going to do is I'm going to select every file except for the kernels. That way I don't have to extract the entire thing, then delete those files. I can literally just extract just the boot images right now straight to that G drive. So I'll do that. So this should be extracting everything except for those kernel images straight to the G drive. So that should be done. Now if I go to my G drive, there it is. So everything is here now from that boot folder without the kernel images. Now it says extract the community firmware file and copy all files within the firmware version 1.2.0 directory into the same boot directory. So let's open that file. No, I'm not interested in buying that, sorry. So this should be everything that we want to copy in there. So I'll just extract this to the same location, click OK. Yes to all is what it says. And that should be set then. So we don't have a 4 gig Pi, I'm working with an 8 gig Pi, so now it says eject the SD card and put the SD card into the Pi. So that should be it for now. So let's take a moment to recap what we've been through at this point. We put together the Raspberry Pi. You saw me doing that on the screen here. I put the heat sinks on and the fan and plugged it all in. Then we went through installing Raspbian OS, just booted it up with the SD card that came straight out of the box, installed Raspbian, the OS, made sure it had all the latest updates, and then here on the screen we ran the check for the RPI EEPROM update and validated that current and latest were the same value. Then we went through the process. I yanked the SD card out, reformatted it into FAT32 here, and I did actually have to go into disk management. Check this out. I'll go into disk MGMT, and here is where it was able to bring up all of the disks where I could actually see the SD drive. And when I found the SD drive, I literally deleted every single partition and every single volume till it was totally empty, and then I could format it with FAT32. So I formatted it with FAT32. We downloaded these two files for the official Raspbian Pi firmware as well as the community firmware. I extracted just the boot folder without the kernel files onto that SD card. And then I extracted just the community firmware into that boot folder and then overwrote everything. So now, with that being done, we're ready to boot up this device off of that new SD card with all that firmware. And I'm skipping past this section here on the screen because this is all about if I'm setting up a serial terminal. I'm actually going to be using the HDMI cable to configure it, so I can skip all of these steps down to 3.4. So when we boot it up, we should expect to see this little Raspberry Pi symbol, and I'm going to be mashing the escape button so that it actually takes me into the configuration section. So let's do that. So here we go. I'm pressing the escape button, and now I'm in the config screen. That's cool. All right, so the documentation tells me that my first step is going to be to navigate to the device manager and then enter Raspberry Pi configuration. So jumping back to the Raspberry Pi, I'm going to go into device manager, and then where is it? Raspberry Pi configuration. It's down here. I'll press enter there. Jump back to the screen. We're going to go into advanced configuration, turn the RAM limit off, and then F10 to save the settings. Okay. So let's go to advanced configuration, disable the RAM limit, F10, Y to confirm, and escape to exit. Now if I scroll down, let's see what we can do here. Console preference. The console preference setting only matters if you have an HDMI screen connected to the Pi, which I do. If the screen is not connected, the serial port will be exposed to the booted OS, and ESXI will detect a headless mode. If the HDMI screen is connected, the serial port will not be exposed to the OS. Change the setting to serial if you want to use the serial port on ESXI, which I don't, but let's just verify what they're saying here. Sounds like I don't have to do anything. Oh, and where did I need to go to do this? That matters. Okay, so this is back under Device Manager. So let me exit out of Raspberry Pi. Console Preference. We're using graphical. That's what I want, right? Yep, I want graphical. Let's exit. Now let's check out what we can do next. Okay, the display config. That's going to matter in case we want to set the actual resolution here. That's going to be under, it looks like Raspberry Pi configuration. So if I go back down to Raspberry Pi configuration, display configuration, this is where I can set things like 1080p, 720p. We can just hit all of these. I'll say F10 to save this. Yes. And escape. Jumping back to this, the CPU configuration says we don't recommend messing with this, so that sounds fine to me. I won't mess with this. Then if that's the case, we are on to the ESXI installation portion here, which it does need to install off of a USB. So what I'm going to use here is a little app called Rufus. Rufus is what I'm going to use to put that ESXI ISO onto the USB drive that we can use for an installation. So here it's automatically detected my USB drive that's empty. It's formatted as exFAT. And here's where we can select the ESXI that we want to boot from. So I'll click Select. And here is my VMware VMVisor installer for ARM that I downloaded yesterday from the ESXi Fling. And it tells me exactly, it handles all the formatting options, and it says it's ready to rock and roll. We'll just click Start. It says it warns you that everything's going to be deleted from there. That's fine. I'm good with that. And we'll let it create my VMware VMVisor installer on my USB thumb drive. All right. All done. Now my USB thumb drive is ready to install ESXi on ARM. So here's what I've got. I've got one USB thumb drive that has the installer, the ISO on it. And I've got another USB thumb drive that's going to be the target. So we're going to plug both in, set it to boot from this, the installer one, until it's installed. Then we'll change it to boot from this one where it'll be installed on. So now I'm going to power cycle the Pi so that it detects these new USB drives. Power it back on. Press the escape button. Now we should be able to go into Boot Manager. Oh man, I have no idea which one is the actual boot disk. They're both SanDisks. Shoot, let's just guess and go with the first one. Oh, look at that. There it is, the ESXI installer. How lucky did we get there? ESXI installer coming to life on little Raspberry Pi. So much fun. Okay, so I'm back in the device manager because when I booted it, it said it didn't have enough RAM. That's interesting. In fact, it's telling me right now only 3 gigs of RAM. Let's go into the device manager. I thought we had already changed this. Raspberry Pi configuration, advanced configuration. Yeah, why didn't it take that? Save configuration changes. Yes to confirm. Let's escape. Yeah, so none of my changes were saved here. I guess when you reboot the Pi, the changes don't persist. Okay, so let's save that. Let's try that boot manager one more time. Oh, now we're looking better, showing that 8 gigs of RAM on that Raspberry Pi. Ooh, fancy. ESXi 7 on Raspberry Pi with 8 gigs of RAM. There it is. Ah, I can't believe this is finally working. So much fun. Welcome to the ESXi Fling installation. Enter to continue. F11 to accept. You know what? I've been told that you can install directly on the installer drive. So this is the SanDisk Cruiser is the one that I said I was going to install. It's only 15 gigs of space though. The SanDisk 3.2 Gen 1, that's actually the one that I have the installer on, but I was told that you could install on that. And I haven't done this before, but you know, I'm just going to try it. You know, YOLO. It says the disk will be overwritten. I don't know how that's going to work because that's where the installer is. You know, I don't like this. I'm not feeling as confident anymore. Let's escape out of that. Maybe if we were to make a partition or something on it, that would have worked better. Let's say F1 details. Yeah, I'm going to stick to the 14 gig one just because this is a little demo environment. So let's see here. If you have an existing data, it'll be overwritten. That's fine. US default. Set a root password. How about just admin? Since this is just for fun. Well, let me take admin. Oh, it must be at least 7 characters. 1, 2, 3. 1, 2, 3. Admin 1, 2, 3. Okay, so it does have to be a complex password. All right, fine. You win. You win. The installer will be configured and installed on that. Let's hit F11, and there she goes. All right, let's reboot. I'm going to go into my boot manager one more time. This time I am going to choose the Cruiser Glide, which would have ESXi installed on it. Okay. It looks like it's got an IP address via DHCP 10.10.10.206. Let's go check it out. From here, I'll say https://10.10.10.206. Oh, that's so far so good. Continue on. There it is. And look at that. We are officially on a Raspberry Pi that's running ESXi. This is so cool. Let's create the Datastore. So I'll go to Datastores, create a new Datastore, new VMFS. Oh no, no devices with free space. Do I need... Add an expand an existing VMFS. Okay, let's try some things here. I'm going to plug my USB drive back in and see if we can reformat it with to be a data store. Okay, so a quick Google search has actually yielded some interesting information about ESXi that I didn't know. And that's that to get storage, a VMFS data store built on top of a USB drive, you have to actually disable the USB arbitrator service. You see, when you plug a USB device into ESXi, this service claims it so that it can't be used for virtual machines. This is really so that it can be passed through. Actually, I should say that wrong. It claims it so that it can't be used for storage because this is what it uses to pass through to virtual machines. So we have to stop it from doing that so that we can use it for storage. So we'll let ESXi boot up here one more moment, and then we'll jump into the GUI. We'll disable the arbitrator service. We'll reboot ESXi one more time, and then we can create our data store. Also worth pointing out, this time that I just booted up my machine right now, it automatically booted from the USB drive, so I didn't have to actually go in to the UEFI settings and select it this time, so that's kind of handy too. So shout out to Verton.net for providing us this little walkthrough guide here on how to get this data store set up. Let's go over to 10.10.10.206, and I'll walk you through where we can configure the USB arbitrator service. So we're going to go into Manage here, and under System, and then Advanced Settings, you can actually search for USB. And the one that you're looking for here is USB arbitrator auto start disabled. Your value currently will be set to 0. So you want to do right click and edit this option and set it to 1. Basically, this is saying that auto start of the USB arbitrator service will be disabled once it's rebooted. So you'll right click on this, you'll say edit, you'll change it to 1, and then you'll go back to the host and reboot the host. And as you can see, it's rebooting one more time, so we'll let it boot up one more time after changing that USB arbitrator service setting. So now my host is rebooted after disabling the USB arbitrator service. I'm going to jump back to the full screen option here. Now let's see if we can create a data store using that USB thumb drive. I'm going to create a new VMFS data store, and it's still not there. All right, I don't know what's up with that. One last thing I can try and do is actually unplug and plug in that USB drive hot right now into ESXi. So let me try that. Okay. Let's see if that did anything at all. So now maybe it'll detect that data store. Nope. Did not detect that data store. So let's go to store. Oh, look at that. There it is. Hello. Now I think we're cooking. Okay. Let's edit some partitions. Yeah, let's make the partition there. Let's give it a new data store. I'll call this VMFS USB. Let's just say use the full disk. VMFS 6 is fine. Yep. There we go. Data store has now been created there. Ha! Look at that. Now I've got the data store set up. There we go. We have an ESXi appliance running on Raspberry Pi 4 8 gigs. There you have it, end to end. Now all we have to do is upload some ISOs and spin up some VMs, and we're on the way. That's it. That's how we can get ESXi up and running on a Raspberry Pi 4 8 gig. Thanks for stopping by, y'all. See you in the next one.